Well, hello, amazing people, students, lovers of chemistry, and everyone watching this video. I'm super excited to be here with you up on this next topic that we're taking in the overall concept of stoichiometry. And today we're talking about the mole concept. It's been an interesting series thus far, and I trust you've been getting massive value for what has been consistently put out in this series. So let's get into what we have for today's video. So let's start by defining what the mole is. What the mole is. The mole actually is one of the simplest ideas in chemistry. And there's a reason why I'm saying it's one of the simplest ideas in chemistry. I want to take out the confusion in this introductory video of what the mole is to help you understand it in a simple way. So let's begin by saying what it means. Before we do that, it's important to note that a mole is simply a special counting unit used in chemistry. Now, in the world today, we have different counting units that are used in different concepts. For example, when I say a dozen, I am simply referring to 12 items. So if I say a dozen eggs, for instance, I am simply referring to 12 eggs present. When I say a score, I'm referring to 20 items. When I say a century, I'm referring to 100 years. You see, all these counting units refer to specific numbers that are grouped into a single unit. In the same way, chemistry has its own special counting unit, and that unit is called a mole. It's called a mole. So instead of counting several units of one thing, one, two, three, four, five, and so on and so forth. How about we just group all of them into a single unit and refer to them as the mole? That's what we refer to as the mole in chemistry. So how many units make up one mole? That's the next question that we're going to be answering. Well, one mole contains 6.02 multiplied by 10 raised to power 23. That's a pretty huge number. And that number, interestingly, is referred to as the Avogadro's number. So in chemistry, when we want to count a huge number of particles present, we do not need to go through the route of going after 1, 2, 3, 4, and so forth. It will be so tiring. We use the mole instead. And the mole says that 1 mole of a substance contains 6.02 multiplied by 10 raised to power 23 particles. Now, those particles could be molecules, they could be ions, they could be atoms, whatever they are. But that number is also referred to as the Avogadro's number. So this simply means that 1 mole of atoms contains 6.02 times 10 raised to power 23 atoms. Just like if I say a dozen eggs, I am simply referring to 12 eggs. In the same way, when I say 1 mole of atoms, I'm referring to 6.02 times 10 raised to power 23 atoms. I guess it makes sense at this point. If it does, go ahead, like this video, subscribe if you haven't, and share to as many people as you can so we can reach more students. So 1 mole of molecules contains 6.02 times 10 raised to power 23, and 1 mole of ions contain the same number of ions. If you notice, the number stayed the same, only the type of particle changes. And so if I say I have 1 mole of eggs, what does it mean? It means I have 6.02 times 10 raised to power 23 eggs present. That's a whole lot of eggs. But at this point, it makes pretty much sense. All right, let's proceed. So let's check out some examples to consolidate the concept of the mole and see if we can make some progress. Question number 1 says, how many particles are present in 1 mole of sodium atoms? Remember, 1 mole contains 6.02 times 10 raised to power 23 particles. And the question says 1 mole of sodium atoms. So it therefore directly means that 1 mole of sodium atoms contains 6.02 times 10 raised to power 23 sodium atoms. Easy peasy. Let's check out another example to buttress what we're talking about. Example number 2 says, how many molecules are present in 1 mole of water? We know that 1 mole contains 6.02 times 10 raised to power 23 particles. Now this time we're being asked how many molecules are present in 1 mole. So it therefore means that 1 mole of water molecules will now contain 6.02 times 10 raised to power 23 water molecules. Can you see how each of these things are playing out? Simple, easy, and straight to the point. All of these things are just to buttress what the concept of the mole is. So here is one common mistake, or here are some common mistakes that students make when dealing with the concept of the mole. Many students usually think that the word mole refers to mass. It is not so. It does not. A mole is simply a counting unit. Just like if I say dozen, I am not referring to how heavy or light something is. I am referring to how many things are present, which is 12. In the same way, when I say a mole, I'm not referring to the mass of a substance. I'm referring to the number of particles that are present. So talking about mass, we'll move into that as we progress in this series. But the summary of all we've been saying since the commencement of this video is chemists invented the counting unit called the mole because atoms are too small to count one by one. You can't even see them with your naked eyes. And a mole is simply chemistry's counting unit, 6.02 times 10 raised to the power of 23 particles. 1 mole contains Avogadro's number of particles, and that Avogadro's number is this number that I just wrote over here. And then a mole counts particles, not mass. It counts particles, not mass. The type of particle may change. It may become a molecule, it may become an ion, it may be an atom, but in as much as the counting unit remains the same, the number also remains the same. I trust you got massive value for everything that was put out in today's video. So before we move on to the next topic, we have some practice questions that I'd like you to try out your hands on. First, why did the chemists invent the mole? Second, what is the main purpose of the mole? Third, state Avogadro's number. And then fourth, calculate how many particles are present in 1 mole of oxygen molecules, 1 mole of hydrogen atoms, 1 mole of carbon dioxide molecules. Let's see if we have some more practice questions. Yes, we do. Number 5, complete the following. A dozen is equal to how many items? Complete it. B, 1 mole is equal to how many particles? Also complete that. And then 6th, true or false? A mole is a unit of counting. Is it true or is it false? Secondly, a mole tells us the mass of a substance. Is it true or is it false? Thirdly, 1 mole always contains 6.02 times 10 raised to the power of 23 particles. Is that true or false? Then lastly, atoms can easily be counted one by one in the lab. Is that true or is that false? Go ahead and answer those questions, and I'll be looking forward to seeing your replies in the comments. Up next, we're going to be dealing with the relative atomic mass and the relative molecular mass in stoichiometry. It's been an interesting series thus far, and I trust you're getting massive value. Up until I see you in the next video, my name is David, an online chemistry tutor for high school kids, and I'll see you in the next one. Till then, stay blessed.